Now, if you have never heard of a design pattern, you might wonder at this point, what is the big fuss about? So, a design pattern is a named solution to a problem in a specified context. And that makes it some kind of reusable design knowledge. It's object oriented, and its name is very important because it allows designers to refer to it. And that increases the bandwidth of communication if you want. There are no standard for how you describe the patterns. There are multiple publications, each one come up with their own way of describing the patterns. And most designers will refer to the Gang of Four patterns as the groundbreaking way of doing things. So when we describe a pattern, at minimum, we have to give it a name. And the name, as I said, important for the bandwidth of communication so we can refer to it. We have to describe what problem it's solving and typically also in what context of interest. And then it would have a given solution for the problem in that context. And that's really all it is. So we're trying to describe something that is reusable, that we think might be applicable in multiple settings. Eric Gamma and company, or the Gang of Four, learned from the Christopher Alexander how to do this. And the Alexandrian form has a concept of a title, which I call name, a prologue, a problem statement, some discussions, then the solution, a diagram that may show what the architecture might look like, and then some epilogue. But there are other forms that have been created along the way. Canonical form, there's a Couplins form, so the one that he used in his book, of course, the Gang of Four. Cockburn, he created a set of patterns for project management, and he had a form. There's a Portland form, there's a Beck form, Fowler form, and Siemens form. So it seems like most books add their own form, but all of them would have at least these three minimal properties: name, a problem in some context, and a solution. Since the patterns I'm describing are from the Gang of Four book, I should acknowledge the Gang of Four form. And if you buy the book and you use that along with this video, for instance, then it's important that you understand that form. And it will give the pattern a name, and that name is very important. There is a classification in the Gang of Four, so they get classified into a behavioral, or they may be structural, or they may be creational patterns. If there is an alias, then they would also mention something like this. There is a motivation for the pattern, it's specifying where it's applicable, there is a description of the structure, there is a definition of the roles called participants, there is a description of the collaboration that is required for the pattern to work, and then there's a discussion of the consequences of applying the pattern, and then there might be some implementation hints and sample code, and also some known uses of the pattern, places where they know that this pattern has been used. And there may also be a set of related patterns. So they feel like in some cases that one pattern may be related to another pattern or be used together with another pattern. So there's a concept of trying to build a relationship between the patterns in the Gang of Four book. Although I may discuss all the aspects of the Gang of Four form, I'm going to try to stick to a slightly more simple format that I've found to be very useful when I'm presenting this. The default way I'm presenting things is by showing you an example of a problem, then I will try to abstract that problem. Then I'm going to solve the example with a very concrete solution to the example, and then abstract the solution, and that makes up a pattern. There are some cases in the course, particularly when it comes to creational patterns, I may create the pattern language or put the patterns together. And I also do that in the pseudo delegation patterns, is a category that I invented, but there are a set of patterns that I find very related. Let's take a look at an example of what that means. So the first thing I mentioned was a concrete example. Let's say, for instance, that I want to talk about the shopping list. I went to Home Depot. When I got home, I realized I'd forgotten to buy some nails. Okay, so that's the concrete example. And then I will abstract that and say something like, well, sometimes when I go shopping, I forget things. And then I will go to a concrete solution. Oh, for instance, when I went to the Home Depot, I could have written a list like this, that I needed a hammer and a nail. And as I picked up the hammer, I could have put a little check mark. And I would immediately seen that I didn't have nails. Okay, so that's a solution to the concrete example. And then in the abstract solution, I would basically say, when shopping, you may sometimes forget things. When shopping is the context, my forgetfulness would be the problem. If you write a list that follows some particular structure, this will be a good solution. When you read the Gang of Four, they tend to focus very much on the abstract problem, the abstract solution. And then, of course, we need a name. So in this case, I could name this pattern the shopping list pattern. That would be a full description of the pattern. Anyway, that's the form that I'm going to use most of this course. We strive for a couple of properties for design patterns. One is to find the correct abstraction level. So we try to make sure that it's language independent. The other thing we're trying to do is to make sure that it's domain independent. So language independent means it wouldn't make much sense if a pattern only worked in one language. So we're trying to abstract away from that so it would be applicable to any object-oriented language. It would not be okay, for instance, if we had something like this is a pattern of how to implement an insurance policy within a insurance company. It may be a pattern. We could create a pattern language around insurance, for instance, but it's not a design pattern at the level of the patterns that I'm going to try to teach you in this course. The abstraction level is interesting because there has been a set of books that by themselves are very interesting in which we cover patterns in various domains. So, for instance, there is a great book by Martin Fowler on analysis pattern. There is also a book on architectural pattern. There are things on design patterns, which is where my focus is right now, but there are also language specific patterns or idioms, as I'm going to call them. So, analysis patterns could be something that says, okay, while you're analyzing a domain or you're writing a specification, these are some common patterns in, say, data structure or how you abstract this, or maybe in business process and so on. Architectural patterns are more structures that often incorporates a set of design patterns. So these could be things like the model view controller, the model view presenter, communication layers, for instance. We have the design patterns that we're covering here, and we have language specific patterns where someone has written up how to do something, say, in JavaScript or in C++. Now, there are a set of brilliant books that have been written around certain topics. So, for instance, we have Enterprise Integration Pattern, an excellent set of books that talks about how to integrate various enterprise components or systems. We have the JEE patterns or the J2EE patterns, as they were called when the book came out, called core patterns. And actually, some of the patterns from that structure has penetrated the design patterns world. And for instance, they had something called a data transfer object, first called value object, often called a DTO now for data transfer objects. That has become a very common pattern and probably should have been a very good candidate for the Gang of Four as a pattern. You have books on game programming. There's a book called Game Programming Patterns. There are things on mobile design pattern, SOA patterns, service oriented architecture patterns. There are patterns on parallel programming, on searches, and so on. This course is going to focus entirely on some generic object oriented design patterns. Often, an architecture or a framework or a platform is a set of patterns synthesized together. So, for instance, the Java Spring framework uses patterns like proxy, adapter, singleton, facade, template, method. So often these platforms or structure that you see that we're using to build Java applications on are a combination of a set of patterns. And in those frameworks, it's very important to have the patterns vocabulary. So you know when someone says, oh, this is a proxy, that it is different from, say, an adapter or a facade. When you master the patterns, you will find that you're able to communicate with other designers that also know the pattern with a much higher bandwidth. The story that is in this slide is actually a real story from a client that we had in the company I'm with right now, where one of my colleagues was explaining what he had done for a client. The story went something like this. I designed a system for a client X that connected a set of devices in a hospital. I decided to arrange the devices using a composite pattern. I used a remote proxy to talk to the devices, and then to control the devices, I used a command pattern. I combined that with a composite pattern to create complex commands. To get the feedback from the devices, I created a reverse proxy and used the observer pattern to pass events up the chain. The structure ended up being a little complex, so I added a facade for interactions, and I also included a builder for configuration. Now, when my colleague was explaining this to me, I was actually on the speakerphone in a class, and the students were totally perplexed what he was talking about. But I could go up to a whiteboard and draw out the whole class diagram. I have a very good idea of what his design is. So if you master the patterns, you are able to communicate with other people and know the patterns at a very high bandwidth. And being able to communicate the design at this abstraction level is very important. When creating this course, I decided to create all the examples in Java. And that might actually feel a little bit like an oxymoron because design patterns, as I mentioned earlier, should be language independent. However, it's always useful to, in some of the patterns that are very code specific, to show examples in some code. Because I'm using Java, there are certain things that may have been more appropriate to use when I'm showing you the solution. So in Java, for instance, we have a few things that probably was not envisioned by the Gang of Four and certainly not assumed when they were defining the patterns. Things like reflection, for instance, or anonymous inner classes, or maybe even closure, which is coming in Java 8, dependency injection, aspects, if you use aspect J. There are a set of these constructs that you can implement in Java in a very specific way. I'm going to try to stick to the Gang of Four. Sometimes I'll mention that if you're in Java, you can use one of these techniques. But there has been paper basically focusing on how you could avoid using those patterns if you had some of the more modern language features. I'm aware of a paper that was written on Aspect J where they claim that 15 of the 23 patterns in the Gang of Four book could be implemented more elegantly with Aspect J. But that doesn't diminish the value of the pattern as a way of communicating and as something that you need to understand as a concept. And finally, before you start going through this course, I have some recommendations for you. The first one is don't try to go through the whole pattern catalog at one sitting. I would suggest that you learn one pattern at a time. Think about where you can apply it, try it out, figure out where not to use the pattern, which is equally important as where to use it. And I would also suggest that you try to set up study groups where you have more than one person going through the pattern and where you can discuss it in a group and discuss where to use it. If you can discuss it with your colleagues, the better, because then often you can talk about where those patterns would apply in your current project. Well, with that, I think we've set the context for this class. The next chapters will be all about the design patterns. See you for the next pattern.